Good morning to you all. We are going to continue our lecture for today, and the topic is unit step function. Unit step function. Maths 204. Unit step or Heaviside function. The first thing is notation. Notation. U subscript A T equals U into bracket T minus A is the unit step function, the mathematical representation. U subscript A T or UT minus A for the unit step. Or we can write H subscript T equals H into bracket T minus A. So these are the notations. Now, the second thing to consider is the importance. Why are we doing unit step or Heaviside step function? We realize that in certain differential equations, like this second order differential equation, this is the second order differential equation with constant coefficients, we realize that f of t, this f of t is piecewise continuous. It's piecewise continuous. When I say piecewise continuous, we mean bits and pieces of functions put together. So this is not the usual f of t being equal to t, or being equal to e to the power 2t, or being equal to any other function, but this time it is made up of a collection of functions. So by piecewise continuous, we mean that f of t will take the form one function, another function, a third function, all with conditions. All with conditions. Let's say T1 ranges between T ranges between this, another T ranges between this, and another T also ranges between that. This is how a piecewise continuous function sometimes may look like. This is how this one may look like. So when we are having such a differential equation, you cannot solve it by the conventional method that we have learned earlier on. So what we have to do is that we have to use a special function called a unit step to compress this. So C, we are now going to do the mathematical definition of unit step function. So mathematically, ut minus a is given as 0 and 1, where this is between this and that also has the condition that's. Mathematical definition of unit step is ut minus a equals 0 and 1. 0 and 1 in electrical systems or electrical engineering, we use it to switch on and off circuits. So this one is a switching off at this and we switch on at that. Graphically, we'll have u of t minus a here, then we have the t axis there. T is between 0 and a, so there's 0 here in the t axis. There's 0 and a, so in the t axis there's 0 here. I can put my a here. And in the ut minus a axis, that is this one, ut minus a axis, the numbers are 0 and 1. So I have 0 here, I have to create 1 here. So now, we are going to draw this two. We have the vertical axis is 0 between 0 and a. The vertical axis, okay, the vertical axis is 0 between 0 and a. So between 0 and a, you're supposed to draw 0. between 0 and A, between 0 and A, we are supposed to draw a vertical line of 0. A vertical line of 0 is still here. So between 0 and A, so it means we have this. And it is closed at A. Sorry, at 0. It is closed at 0 and open at A. So we are done with it. And in the t-axis greater or equal to A, in the t-axis greater or equal to A, the number is 1. So we have the vertical line here is 1. This is the vertical line, is 1. From here going. So if t is greater than or equal to A, means we are here going. And you shade here because t is greater or equal to A. Greater or equal to. So we shade here. So this is the graphical representation of the unit step function. Okay, so now that we have a fair idea of what a unit step function is, we know the notations, this is how it's being written. We know the importance that when you have differential equations with constant coefficients, but the non-homogeneous term f of t it's not continuous, but it's piecewise continuous. In such a situation, we use the unit step or the Heaviside step. And this is an example of how a piecewise continuous function should be looking like. And this is the mathematical definition of unit step function. And this is how it is being graphed. Now we'll pick questions on how to express functions in unit step.